And now for something completely different. I'll bet. What could be more different than a unicorn on a moon with 5 legs? Well, anyway, you probably didn't see this coming. Lunar railroads. Okay, I'll bet you not many people here have thought, what are we going to do? When are we going to put railroads on the moon? Well, people are thinking about that now. There's 2 studies funded by the government right now that are doing that. One of them is the Defense Department, DARPA, the people who brought you the internet. They're actually a pretty important research group. And we talked about their study. They're actually funding lunar infrastructure research right now. They don't say it that way, but obviously they don't think NASA is doing enough. And we covered some of the other projects, which sounded actually a lot more reasonable. This one's a little more questionable in my mind. And then NASA also internally funded their Propulsion laboratory in California to also study this. And we'll talk about both of those. But the goals in both of them are supporting daily operations in the 2030s. The thing is, we don't even have any official missions to even build anything right now. A lot of individual research has been done at NASA, but the Moon to Mars program, it doesn't cover any of this kind of stuff. It just kind of assumes someone else will do it. And this is the people doing it. Northrop Grumman is the one who got the funding from DARPA to do a study on this. And this is not from them. Let me make that clear. That picture, that's just a made-up picture. But in spirit, it is pretty much the same. There's 2 ways you could imagine building railroads. I mean, one of them is say, just take every little part and everything we do on Earth and just do the same thing on the moon. But make some allowances. Gravity's different, and that's what they're doing. And then JPL kind of went the other way. We'll get to that. But why do you even want to do this? Well, you do have a transportation need, ultimately. Once you have a significant civilization going, you got an industry. You're going to be mining. You're going to be pulling in stuff to get water out of it. Maybe you're pulling it in to start making solar cells or get out the titanium and aluminum, that kind of stuff, for construction purposes. Even just getting the regolith to cover up your structures to protect yourself from radiation. You need to use the local resources. So you're going to need something, and you're going to be doing mining kind of operations. So that's one thing. And the other thing is just getting around the base. And in particular, you don't think about it much, but landing zones. Well, it's pretty hard to land all that accurately. I mean, actually, nobody has managed to land that accurately on the moon. That Japanese slim lander was the only one that's ever really come close to doing that. You can't land necessarily 100 feet from where all your facilities are. So you need something to transport you to a little further place. This is an actual slide from Northrop Grumman. I wouldn't have thought anybody could make railroads on the moon boring, but they managed to. I mean, they pretty much just took a catalog. The kinds of things, but what they're doing is actually quite reasonable if you assume, let's do what we did on Earth. Well, we need tracks and we need switching gear. One thing that's a little bit different is the construction equipment for laying the track and for building and creating the track, but that's a different issue. That's under construction and maintenance. Then you figure, okay, you're going to have different kinds of flatbed trailers and you're going to have tankers. It's actually hard to imagine not having all that stuff, but somebody has to write it down and start thinking, how are we going to do it? Well, and that's what they're doing. So this is their vision for a train, sort of reasonable in a lot of ways. I think it's kind of questionable that small amount of solar cells is really going to provide enough power, even during the daytime. And obviously, it won't do it at night. They made allowances for that. They said, okay, well, at night you fold in the solar cells. Okay. They are addressing design issues like the lunar regolith. This is one of the biggest things. You'll sink in it. They called it soil, the dirt, the regolith. People that have a biological bias object strongly to the use of the word soil. It's a regolith, it's dirt, it's crushed up rock and this and that, until it has biological components in it. On Earth, there isn't that much of a distinction. Okay, maybe the sand in the middle of the worst desert, the Atacama Desert or something. Yeah.
Do you know if they're considering the magnetic rail at all instead of just regular
That's the NASA one, which I'll get to in a minute. Yeah, these people know they're thinking normal wheels and and everything else, tracks. So you can see it, pretty much it's on tracks. So you deal with a regolith that's different, kind of crushes down. The real problem is how do you make the steel or whatever you're using for the rails in the first place? That takes a lot of energy. And the other thing is gravity. You don't think about it much, but with a lower gravity, you're going to have to bank more. If you go around a turn, you got to deal with that. They've been thinking about these kinds of issues. So if you're starting off saying, let's reproduce Earth railroads, there's your project for you right there. And you can't really dismiss it completely, other than wondering, is the population density and industrial density really high enough to justify rail in the first place? Realistically, I think you're going to be using little electric cars for a while here. But at some point, when the population density goes up, you start to worry about this. So let's talk about what JPL is proposing. This is more outside the box thinking. That would be a more modern version of Rodin's thinker here. They came up with something called float, which was flexible levitation on a track. and they need magnetic. It's a maglev kind of an approach, but it's not even like the ones you see on Earth. It's actually something rather different. This was awarded a NIAC award. We've talked about those before. This is the NASA Innovative Advanced Concepts. Every year they fund projects which are supposed to be kind of leading edge, cutting edge kind of things. This is a phase 2 award, so that means they've already passed a phase 1 project. They made it this far. Phase 2 is limited maximum of $600,000. I don't know what the other one was. It's probably more. And this is what it looks like. It doesn't look like your average maglev train that you'd see on Earth. Not that there are that many, but it's different. They're envisioning it as a flexible membrane kind of thing. It would be laid down from a vehicle. You kind of roll it out like carpet. Think of it as a carpet runner. There's some advantages to that. Well, one is if you decide you want to move it, you just roll it back up and take it and move it somewhere else. They don't do any road preparation. They just kind of do it. Now, how you're going to actually keep everything on those tracks is not at all clear, or certainly when you want to go down into a crater. But the big advantage cited is you don't have abrasion from dust so much. This design, they're actually seeing it as autonomous vehicles, and the vehicles themselves are unpowered. All the power is done through the track itself. There's a graphite layer, which I think mainly is just probably for protection. There's a flexible circuit layer, and that's what actually controls the thrust. How they're going to make that work, I don't know. There are no details available on that. And then they might have a thin film solar panel to provide some power as well. That's optional. The magnetic levitation supposedly minimizes a lot of the dust abrasion. I would think it actually could get in the gap and still screw things up, but who knows. The tracks unroll, they're flexible, you just roll them out. The good thing is it doesn't take a lot of construction. Building Earth-style railroads takes a lot of construction equipment, a lot of digging. You avoid grades, and of course, if you have craters, what the heck do you do? Well, actually, this doesn't solve the crater problem. It's kind of hard to imagine putting this over the edge of a crater either. So these are all things to be determined. Ever wonder about what exactly do these people deliver if you haven't worked on research projects before? Well, there's a couple of things. There are deliverable items for a project like this. One is you're going to do some prototyping. That'll be on Earth, obviously, and some kind of a test bed. So they'll have some kind of a simulation with hardware vehicles of some sort or another. And the other big thing will be some kind of a technology roadmap, sort of saying, what are the design factors? You worry about gravity being different, the high temperature, low pressure, all those kinds of things. Identify the factors, identify the gaps. What don't you know how to do yet, where you have to do further research. And then manufacturing. Serious manufacturing issue here. Either you're going to import a bunch of rail from Earth, which seems unlikely. Part of this project, what's hidden, the real effort is how do you make all that rail in the first place? Not so much maybe for this stuff, but certainly for the rail alternative. And then risk mitigation. How do you minimize all the various risks? So anyway, that's what they will be delivering as part of this.
This topic led to a discussion on the importance of developing in situ resource utilization, that is, making things on the moon with local materials rather than paying for freight from Earth.
Yeah, it would be way too expensive. Now, the reality is, of course, we don't actually have the technology to make it on the moon yet either, but this is all a process that has to gradually take care of itself. There's projects underway to figure out how to extract metals from the regolith as well. Basically, you melt it. Almost everything says you're going to melt it, which means you have to have a lot of energy. So that also means you have to solve the problem of having enough energy, which means you probably need nuclear reactors, which, by the way, the Chinese are doing. I don't know that we're really doing that.
Doug Hall suggested that you could just use solar power to produce materials during the lunar day.
Yeah, you could. It's just that's 14 Earth days of darkness. The real problem is just the sheer amount of energy it's going to take. And then how inefficient it is if you have to wait 14 days every time for the night to finish. 14 Earth days. Okay, my immediate reaction is, if you're going to do something like this, why not do some kind of a tramway? When you get down to it, ski resorts do this. I actually saw a small village in Italy where they didn't really have a decent road going to it. They used trams, and they didn't even transport people. It was for cargo. They brought stuff in and out. When I first saw it, I was kind of laughing, thinking, oh, this is so primitive. But actually, it was a perfect solution for their situation. They had terrible access, and it's not that hard to build this stuff. You can go over craters. You can go over mountains. It's not that hard. These things, obviously, they're not going to be up that high, but fundamentally, they just have to be high enough to be off the ground. You may have expanses like that when you're going over a crater, but that's the only way to do it. Running a road, whether it's on maglev or whether it's on rails, either way, going down into a crater, it just is going to take a lot of excavation to smooth out the grades. You don't need so much material to build it, to do much to the ground. You don't have to do anything really, as opposed to building roads, basically. You can cross that rough terrain. The South Pole, which is where everyone wants to go, it's very rough. There's a lot of craters, it's craggy. That's why there's so much trouble landing there. And you get less dust. And that's in operation. The dust has an electrostatic component to it, and that's part of the problem. Just running by, you generate enough electricity that with the charged dust that's already there, you tend to stir it up or attract it. And that's a problem you generate. And also, if you're up above it higher, you're not going to attract it either. So either way, you're avoiding a lot of the dust.
There's simpler, less expensive solutions than gondola-type tramways. A simple solution would be more like a chairlift. You have a cable rotating on pulleys in a loop. From that cable, you hang chairs to sit on and maybe hang on. And for cargo, you could attach baskets or hooks.
So we'll have to do a NIAC proposal for this, obviously.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.